Cloudflare shaved about 100 terabytes of memory from the cache behind 1.1.1.1. OVH Cloud says AI demand has helped push memory costs up roughly sixfold. And AWS added a fourth availability zone in London, exposing infrastructure that quietly assumed there would always be three. This week is mostly about assumptions that work fine until scale or reality changes underneath them. I'm Brian Teller from Teller's Tech, and this is Ship It Weekly. Welcome back to Ship It Weekly, the show about the DevOps, SRE, cloud, platform, and security stories that matter when you're the person that keeps the thing running at 3 in the morning. For the weekly story list and source links, check out oncallbrief.com. For past episodes and show notes, head over to shipitweekly.fm. This week, Cloudflare shows what saving a few bytes means when you have more than 250 billion DNS cache entries. OVH Cloud is raising infrastructure prices as AI changes the memory supply chain. AWS added a fourth availability zone to London. And Route 53 Global Resolver is getting a better model for cross-account DNS self-service. Then we have 4 quick lightning round stories and a human closer about something that almost every Kubernetes engineer eventually worries about: running the right command against the wrong cluster. Let's get into it. First up, Cloudflare published a really good engineering deep dive into the cache behind 1.1.1.1. Cloudflare's DNS services hold more than 250 billion cached DNS entries at any given time. At that scale, one wasted byte per entry is more than 250 gigabytes of memory across the fleet. So Cloudflare went looking for bytes, not more servers, not a new caching layer, bytes. They made 5 changes to how cache entries are represented and stored in memory. Together, those changes cut the memory footprint of each entry by more than half. Across the fleet, Cloudflare says that freed roughly 100 terabytes of RAM. And performance improved too. Insert throughput went up 43%, and lookup latency dropped 19%. That is what makes this one interesting. We tend to think of optimization as a trade. Spend more CPU to save money, add complexity to reduce latency. But better memory layout and fewer allocations can make the whole system faster and smaller. It also shows how different optimization looks at scale. If your application has 10,000 objects in memory, shaving 8 bytes from each one probably does not matter. If you have 250 billion of them, suddenly the exact layout of a Rust struct matters a lot. Premature optimization is still real. But once you find something that exists billions of times, tiny inefficiencies stop being tiny. Sometimes the big infrastructure optimization is not a new architecture. It is one field in a struct. Next, OVH Cloud is raising prices on some infrastructure starting in September. And the reason is memory. OVH Cloud says RAM costs roughly 6 times more in June than it did a year earlier. Suppliers are shifting manufacturing capacity toward high bandwidth memory for AI workloads, which is affecting the supply and price of more traditional RAM. Some newer servers are reportedly going up around 40 to 59%. Certain gaming servers are increasing even more. This is a good example of the second order effects of the AI infrastructure boom. You do not need to run an LLM. You do not need GPUs. You do not even need an AI project. You can still end up paying for the demand AI creates further down the supply chain. For FinOps teams, this changes some assumptions. Right sizing still matters. Commit discounts still matter. Reducing idle capacity still matters. But none of that completely offsets the underlying hardware becoming dramatically more expensive. It can also change whether an optimization project is worth doing. Maybe nobody cared about squeezing another 20% out of a memory heavy database cluster last year. A 50% infrastructure price increase can change that calculation quickly. Cloud abstracts the hardware. It does not make hardware economics disappear. Eventually, those economics show up in the invoice. Third, AWS added a fourth availability zone to the London region. The new zone is EU-West 2D. More capacity and more fault isolation are obviously good things, but some customer automation immediately exposed an assumption. London had 3 availability zones. Maybe Terraform discovers all availability zones and creates a subnet in each one. But the module only has 3 CIDR blocks. Maybe there are 3 NAT gateways, 3 route tables, 3 entries in a configuration array. The code was dynamic enough to discover the 4th zone. The architecture was not dynamic enough to support it. That is a subtle difference. Dynamic discovery does not automatically mean dynamic compatibility. If a module supports exactly 3 zones, validate that and fail clearly. If it is supposed to support any number of zones, make sure every dependent resource actually scales with that number. Do not let a cloud provider adding capacity accidentally change your production architecture. Cloud APIs are dynamic inputs. Regions change. Services expand. Instance types appear. Availability zones get added. Sometimes the cloud provider changing underneath you is not the outage. It is just your assumptions finally getting tested. Fourth, AWS published a useful pattern for shared DNS views with Route 53 Global Resolver. The cross-account capability itself is not brand new. The operating model is what I like. In a typical multi-account AWS environment, a central networking team owns DNS resolution. That makes sense. You probably do not want every application team independently changing the organization-wide resolver. But application teams still own their services. So when they create a private hosted zone, somebody has to make that zone visible through central DNS. Historically, that often becomes a ticket. App team creates the zone, networking team gets the request. Networking team associates it. App team waits. That works with 5 teams. It becomes a bottleneck with 50. Shared DNS views let the networking account keep control of the resolver, while application accounts associate their own private hosted zones through AWS Resource Access Manager. The platform team keeps the guardrails. The application team gets the self-service action it actually needs. That is the balance I like in platform engineering. Centralize the decisions that need governance. Delegate the actions team can safely own. You are not removing control. You are removing a human scheduling dependency from a routine deployment path. Quick lightning round. First, some strange hardware security research. A project called Skitter Creek Bath Salts demonstrates manipulation of memory controller translation registers in ways that can undermine security assumptions higher in the CPU stack. This mostly affects older AMD families and requires significant privilege in practice. So, this is not a panic and patch story. But it is a useful reminder that higher level security boundaries only protect what they can actually see. Second, eBPF host routing is now generally available in Advanced Container Networking Services for AKS. Routing and masquerading can move away from the traditional IP tables path and into eBPF, which can improve latency, throughput, and CPU usage. But host level IP tables rules are bypassed. So understand what your workloads and node tooling depend on before you flip the switch. Third, CloudFront Functions has a nice observability improvement. Functions can now add custom context directly into CloudFront access logs. That means less work correlating separate function logs with the request that triggered them. Small feature, much nicer debugging. And fourth, Go 1.27 is out. The headline language feature is generic methods. There is also improvements around type inference, JSON, UUID support, runtime profiling, and tooling. If Go is a big part of your environment, this is worth actually reading the release notes instead of just bumping the version in CI. The human closer this week is about a mistake that is painfully easy to make: running kubectl against the wrong cluster. The scenario is simple. You have multiple terminal tabs open. In one tab, you switch Kubernetes context. Later, in another tab, you run a command believing you are still pointed at the environment you were using before. The command works perfectly. That is the problem. kubectl context lives in the kube config. It is not tied to your terminal tab. So if two shells use the same kube config and one changes the current context, the other silently sees that change too. No warning, no authentication failure. Your command just succeeds against a different cluster. Those failures are dangerous because the system behaves exactly as designed while violating the operator's mental model. If kubectl crashed, you would stop. If authentication failed, you would investigate. But if a delete command succeeds against production instead of staging, everything technically worked. There are some simple protections. Show the current cluster and namespace in your shell prompt. Pass the context explicitly for destructive actions. Use separate kube configs or session scoped contexts, and add deliberate friction around production. I like that last one. We spend a lot of time removing friction from engineering workflows. Usually that is good, but not all friction is waste. Typing the production cluster name before a destructive command costs 5 seconds. That is cheap compared with restoring a namespace because muscle memory moved faster than your attention. And the strongest protection still belongs upstream of the laptop. RBAC, emission policy, scoped credentials, guardrails that limit how much one accidental command can actually destroy. This connects back to the AWS availability zone story. London has 3 AZs. This terminal is pointed at staging. This array will always have 3 entries. This kube config belongs to this shell. Those assumptions can be true for years. Then one day, they are not. Good infrastructure engineering is not eliminating assumptions. That is impossible. It is knowing which assumptions can hurt you when they stop being true, then either enforcing them or designing around them. If the module only supports 3 zones, validate 3 zones. If a destructive command must only run against staging, make staging explicit. If production deletion is dangerous, put a control somewhere stronger than someone remembering which terminal they used 20 minutes ago. A lot of incidents happen when reality changes before our mental model does. The boring fix is making reality harder to misunderstand. That's it for this week of Ship It Weekly. We covered Cloudflare saving about 100 terabytes of memory in its DNS cache, OVH Cloud's AI-driven infrastructure price increases, AWS adding a 4th London availability zone, and cross-account DNS views with Route 53 Global Resolver, plus hardware memory isolation research, AKS eBPF host routing, CloudFront functions unified logging, and Go 1.27. Follow or subscribe wherever you are watching or listening. You can find the weekly story list and source links at oncallbrief.com and past episodes and show notes at shipitweekly.fm. I'm Brian Teller from Teller's Tech. Thanks for listening. And remember, the most dangerous assumption is usually the one that has been true for so long that nobody remembers it is an assumption.